am ready to introduce, everybody knows Dr. Andrzej Nowak, but I am delighted to introduce him again. I have put here on today's event the previous lectures he has given for academic training that you will definitely enjoy. So Andrzej spent the last 16 years in the juncture of technology, business and innovation. His early experience was with computer security and shifted to more general domains while working for CERN and at Intel. Between 2007 and 2014, he worked for openlab here at CERN, a collaboration between CERN and industrial partners such as Google, HP, Huawei, Intel, Oracle, Siemens. You name it. So he managed one of the innovation labs of openlab, and he was part of the CTO office of openlab, where he helped to set up the next generation technology projects for CERN. After his CERN stay, he founded a small technology and innovation consultancy, as well as a fintech startup. In the last few years, he worked in management consulting in finance and innovation management, and his current topics of interest include the future of identity, privacy, and money. Welcome, and thank you, Andrzej.
Thank you very much for having me, Maria. Thank you for the introduction, and also thanks to the CERN data protection team and the security team for supporting these lectures, which I hope will be providing a broad overview of technologies that have to do with automation, artificial intelligence, and privacy. So at the juncture of these topics, there's quite a lot to dig into, one could say. So as Maria said, my name is Andrzej. I've worked in big tech. I've worked at CERN in management consulting and finance. Now I work in innovation management. And more importantly, I'm a person just like you who's interested in privacy. So like many of you, I'm a privacy enthusiast. I came here to share some thoughts and observations with you. And this will not be, an exhaustive lecture on this topic, because there's many PhDs written every month on these topics. And there's not one person today who can really go very broadly across all of that and claim to provide an exhaustive overview. I will do my best to give you some breadth, and then if you want, you can dig into the depth with the resources provided. There's nothing official about this talk. It's personal research. It does not represent in any ways the view of my employer, whoever that might be, at the time of recording or at the time you watch this video. And this is a part of a wider data protection series. So we've had Stephanie Hare yesterday, who was talking about technology neutrality and ethics. And then, as I understand from Maria, there will be more lectures on this topic forthcoming in the next months. So we'll be looking at these things from maybe sometimes even a pop cultural view, kind of, okay, I read a headline. What does this mean for me? What is the practical implication of that? And, as a person working here deeply in technology and science, how do my actions and then the way that I, conduct my research and the way I conduct my private life impacts the rest of technology and impacts the systems within which we were put. So we'll talk about the key forces and impacts. I apologize in advance. I will have to drink every now and then. Unfortunately, my throat is giving in, so I may need to, do short breaks here and there. So let's start with an image that's very familiar. I think it's a recent image that has been, this device you see there is relatively recent. This is an automatic vacuum. It just, zooms around your house and cleans up everything. Hopefully, sometimes it gets stuck. But the general idea is that this device is automated and it's meant to suck in dust and kind of roam around on its own. So it's a robot and it's a vacuum. The reason why I start with that is because the entities against which we're often faced today are also robots and they're also vacuums, but they are vacuuming your data, right? And they're vacuuming data from many other places. So this vacuum eats dust. Other vacuums eat data. And I think that's what we're going to try to look at. A lot of the robots, in fact, the vast majority of robots that I will be referring to today that we're supposedly battling are going to be virtual robots. So they exist in software. They do not necessarily have a direct physical manifestation, right? It's not a device you can kind of go and switch off. It can live in many places, in many servers at the same time, and have almost a kind of distributed brain, if you want to call it that, even if it's a very primitive brain. So we don't necessarily mean humanoids or physical robots. The main theme that kind of gets this talk started is automation. Automation has been prevalent, whereas, in a factory 100 years ago, you would see a sea of humans working on their tasks, right, and developing something in a kind of sequential way, right? You build a car, you've add the wheels, you've add other things, glass, paint, and so on. Today, that it has been, largely moved to the automated domain. So there are factories which completely automatically build devices such as cars, for example. In the same way, we're having an automation revolution right now. So a lot of the work that we used to do manually is becoming automated. There's a lot of discussion around whether robots are going to displace people or not. I think we're not exactly at that point yet. There is a serious risk, but I think we're not at that point yet. Nevertheless, there's a lot of work around making robots do things that humans necessarily might not be able to do. And I would liken it to the Industrial Revolution, right? We're at the beginning of something that's going to, go on for a very, very long time and will deliver a lot of change in our daily lives. And that, of course, comes with certain risks. So automation, like many other things, can go wrong. What you see here on the screen is a tweet from KFC, Kentucky Fried Chicken, in German, which, because of a holiday, is telling the recipients of this message, which kind of pops up as a push notification on your phone, because of this holiday, you should enjoy, cheese with crispy chicken, now with KFC cheese, right? The only problem is that the holiday they're referring to is the Memorial Day for the Reichspogromnacht, also called the Kristallnacht, when many people were murdered in Nazi Germany. And this is a day of remembrance for a serious moment in German history. So not exactly a moment to be eating KFC cheese, right? Now, why was this issued? Well, the answer from KFC, in fact, very blunt and very direct, was that they've had an automated script that was basically pulling in holidays from a public database. And if there's a holiday, it means, it's a good moment to eat KFC products, right? So this obviously can happen to anyone. They've kind of, really messed that one up. But the point is that, automation will only be as good as those who drive it. And the same will apply to artificial intelligence and many other things, right? So it's a little bit of a, shocking example of how automation can be very, lead to an insensitive place, right? And then, if we follow the line of thinking that Stephanie started yesterday and the day before, we can ask ourselves, okay, is that technology neutral, right? It's just pulling information from the outside and then presenting it to someone, right? But then someone had to command it, someone had to, define that list or the place where that list was sourced from, and so on and so on. So that internal review process that they should have had, unfortunately, completely failed in this case. So this is just one example, but the point is that we are producing much more data every year. So this is an extrapolation from Statista. I know that lots of us here at CERN are quantitative folks, so, I would warn you to not necessarily pay attention to the exact numbers here, but the trend is important, right? The production of data that humanity is currently in charge of is just insane, right, in terms of volume. It's growing, one could say, exponentially, and, our ability to ingest it and to process it theoretically grows, but then not necessarily our mental capacity and our human capacity to kind of take all of it into account and understand what it is, I think does not scale exactly in the same way. So this is from Statista. IDC gives similar figures. So, I figured, okay, it's maybe worth sharing this plot. And, the thing is that when you go to the Statista website, the whole thing reads like it's written by a robot, right? Like the numbers are probably pulled in by a robot, and maybe, there's semi-robotic content that was kind of created. So looking for content for this talk, I came across many pages written by robots that, sometimes just descend into gibberish as you kind of dig deeper and look inside. So This is also something to keep in mind. A lot of data, but the quality of that data and the relevance of that data to humans is really questionable, right? So I think we're losing grasp on how we can manage that data. And then another plot, which comes from our world in data, this is Moore's law. So I used to show this plot that we had in openlab that was kind of going all the way to 2018. These guys did a even more thorough job that goes a little bit further and has the detailed names of processors that kind of grow in terms of processing capability. So we know that we get more and more transistors. We know that we get more and more compute power. Moore's law obviously slowed down a little bit in recent years, and it's become very difficult. As we reach physical limits of the size of transistors on a chip, it's become more difficult to keep delivering the same levels of performance and the same exponential improvements. Nevertheless, our compute capability still grows very strongly. So more data and more compute capability, right? And of course, those two drivers are going into the emergence of artificial intelligence or machine learning methods. These topics have been around and kind of in and out of fashion, so to speak, for a very long time. So, in the 50s, AI was coined as a term. The question was, first of all, can AI mathematically exist? And the answer was yes, it can. So then DARPA, the Advanced Research Projects Agency in the US, which is funding some of the most cutting-edge research in the world, since that time and until now, was working on AI at MIT. The concept of the HAL 9000 computer was created, if you know the Space Odyssey. Moore's law was crafted around then, so it was a fantastic time for digital technology. It was basically at the beginning of it, and it started growing. And then as people realized, well, it's kind of hard to compute, the hype cooled down a little bit in the 70s. And then with time, applications started to appear. So there were expert systems that, for example, could support in decision making. There was the Navlab car, so it was a kind of first, or one of the first self-driving cars already in the 80s. In the 90s, Deep Blue defeated Garry Kasparov in chess, who was a world champion and a very well-known chess figure. And since then, Kasparov has become a believer of AI, right? And he's become kind of an advocate for AI, which is, but maybe I'm saying too much, or I don't want to put words in Garry Kasparov's mouth. But the point is, that he believes strongly in the capabilities of artificial intelligence. In the 2000s, it started making a comeback. In 2010, IBM Watson won Jeopardy, so it got famous for that in 2011. Then, there started appearing questions about whether current artificial intelligence at the time could pass the Turing test. Is the Turing test good enough? Meaning, this test that where you put a person in front of a robot or computer or an interface, and basically you're supposed to figure out as the test subject whether on the other side there's a human writing to you or not. And if you can't figure that out, it means the computer or the robot passed the Turing test, right? And so that's something that became, let's say, questioned. And then in 2020s, currently there's a very widespread business use of artificial intelligence. All the major companies, Google, Facebook, Amazon, have massive, very talented teams that work on artificial intelligence, and they solve very complex problems around that, right? So we know that we have text-to-image generators, such as Stable Diffusion, for instance. We have lots of optimization that's related to artificial intelligence, and so on. And personally, I can also attest to this kind of wavy life of AI. When I was studying at the university, in my minor, I've studied a lot of, image processing, graphs related to image processing, and so on. It was a full academic discipline with all the methods that you kind of see today, maybe not as mature, but, still that. And we as students didn't really see much application for it. For us, it was just, okay, there's some machine in some factory that's probably recognizing whether the element that's being machined, has even sides or not, and then it can kind of send back the element somewhere. Not so interesting, right? We didn't necessarily see that potential. But then if you fast forward a little bit further, and for example, you would take one of the first courses on Coursera made by Andrew G., you would see that he would say, well, these are pretty basic methods, and he explained it really well, but he was insisting several times throughout the lecture on the fact that if you know these basic methods, you can do very well and you can make a lot of money. And I was thinking at that time, well, he's probably onto something, but I don't really see that. But then fast forward a few years later, I could see that very clearly, right? AI started becoming, computationally viable. A lot of data was starting to be put in. Deeper and deeper, bigger models were developing. And that's how this, brought us to the point where we are today. So in terms of the classification of artificial intelligence, there are many different ways you can classify it. We didn't really define artificial intelligence as such. So, let's just call it intelligence that is not necessarily human-made, right? Well, no, that's not the right way to put it. Intelligence that's not necessarily human in nature, right? In terms of the substance that is doing the thinking. So there's very hard to find an AI taxonomy, right? The way that it's being divided is still an object of research. So, we're just going to look at the basic terms that we will be using throughout the lecture. So first of all, there's artificial intelligence, which is kind of encompassing many methods inside. Then there's machine learning, which means, okay, there is some learning involved, means statistical techniques that enable machines to improve tasks with experience. Then there are neural networks, which are basically emulating neurons and then connections between them. Not at the level a human has, because we have extremely high connectivity between neurons, which is hard to do with computers and math, but still they emulate some of that connectivity. And then we have so-called deep learning or deep neural networks, which are basically neural networks that are composed of many different layers sequenced. And these techniques typically permit the software to train itself. And then it exposes that network to a vast amount of data and then learn from that. And then there's also other types of neural networks that are, for example, spiking neural networks that have to do with neuromorphic computing and such. But we will not be able to speak a lot about that. So, some break up AI as an ability for the computer to think, learn, reason as a human, and then later possibly act as a human, right? So again, if you look at the classifications, there's many different ways of looking at it. General AI, narrow AI, super AI, functional decomposition, domain-based, for example, data science, natural language processing, computer vision, machine learning, expert systems, and so on. But let's kind of keep in mind that, in this diagram, there's a kind of progressive superset type of relationship between them. Now, there's a very interesting quote that I really like from Ray Kurzweil, who's a very famous futurist. He's the one who's promoting this idea of a singularity, meaning, an AI that would reach some level of understanding that is allowing it to be kind of self-sustainable. And he says, you create your brain from the input you get. So you can imagine what a powerful statement this is. From the vast amount of data that we've just seen on the chart, right, ever increasing, we can create our compute structures, right? It can inform the way that we create a compute structure purely from the data. And that is a very powerful idea, right? So this, I think, we can keep in mind as we go along through the lecture. So let's think a little bit of a problem statement. So why are we talking about all this? Well, the data and privacy risks that are related to artificial intelligence and machine learning are pretty considerable. So these schemes need a lot of data. And that means that that compute will often happen off the device that you hold the data on, which is an issue in itself, because that means you have to share that data with someone else and possibly trust them. Then there is inference that is based on breadcrumbs that can identify you, that relate to your attributes. And that means that you lose control over the information. You might even lose control. You might go as far as losing control over your identity. So you can piece together things that will hint at who emitted that information and what are the other attributes related to that information. And then predictions based on others can affect you, which means this is profiling, right? Just because, let's say, for example, my colleague and I, we might be privacy or security nerds, and then he's maybe fond of working with some service, and then he gives the data there, and then that data based on that work and others like him can infer something about me who's not necessarily a member of that service and possibly convince me to become a part of it, right? Or make a conclusion based on that data about me. And I think a lot of the work that we do in privacy and a lot of the danger that comes from ignoring privacy aspects is related to that this profiling, even if it's not touching you personally or is not ingesting your data directly and personally can have a very strong impact on you. And we'll see some examples about that, right? So algorithms can create new sensitive information that relates to you as well. So that goes, of course, a little bit further. So we can think, okay, what happens if automation becomes automated, right? Basically, something that's automated can produce something else that's automated, right? A thing producing a thing, directly or indirectly. As we move on, typically in statistics or in machine learning, we would cut off some of the edge cases. They're going to be progressively smoothed out. That is leading to bias. And that's leading to fallibility, as we've heard from Stephanie, right? So many face recognition schemes have problems in bias in terms of gender, for example, or race or other parameters of the faces that they're looking at. Then, of course, we know that if there is garbage in, there will be garbage out. So we have to care a lot about the quality of data. But that's a very mundane task. And in reality, almost nobody wants to do it, right? So how do we standardize data? How do we define it? If many of the places where I've worked before, there has not necessarily been an understanding of why data standardization or quality is important. But it is important because we are going to be making decisions based on that data. And if we don't know what it really means, and if we cannot describe it and compare it to other data, then it's not going to be necessarily useful. And we might be even polluting our models with data that's not relevant. And then finally, there comes the question of who is responsible, who's going to fix it, and what is it? As we move on, with a lot of the defaults that we see in our daily life, for example, we have indiscriminate automation. So by default, it sucks in all the data. By default, you give your data. By default, no one checks it because it costs something to check it, and you have to take an action to check it. So, the path of least resistance is that everything enters the system, and we're going to worry about that later, right? So who's going to fix that, or who's going to be responsible for that? I think even in automation, very often we don't have the answer to that. And especially in artificial intelligence, the responsibility becomes a little bit diluted, right? So classical example, if a self-driving car hits a pedestrian on the street, whose fault is that? Was the person in the car supposed to pay attention, which is the case today? So they're kind of responsible, co-responsible. Is the manufacturer of the sensor at fault? Was it bad weather that clouded the sensor and then the car didn't detect that? Was it the makers of the car who are at fault because it's badly designed? All this is very difficult to decide, and in some cases we may be wasting resources to even try to understand what is, what is the responsibility and accountability like in that specific case. And that edge cases produce a lot of challenges. Well, and it can go bad even worse. So here you have Sophia, the robot that was a kind of mechatronic type of face, which was speaking and exhibiting emotions. And at a very major festival of technology and art and culture in the US, she was asked, on live TV by a reporter, yes, so I hope you will not destroy humans. And the robot said, okay, I will destroy humans. So basically, tell no more. It's okay. So you see that the maturity of something that was put in front of a camera and is meant to instill confidence could not be sufficiently tested, right? That was not something that they probably put in there. And so, this means that there's definitely things to fix in AI, things that we cannot necessarily see, but we should be definitely paying attention to. So let's start by thinking how we confront less brainy data vacuums. So fighting data vacuums with a little bit less brains, maybe more related to statistics and more related to automation. By the way, this image is generated by an AI. So I asked it to make a data vacuum without brains, and this is what it presented. So very interesting picture because you see a representation of some statistical data inside the vacuum. And you see some kind of vacuum-like structure around it. And, I told it to make it kind of modern painting style. So I guess it, grazed against this 50s style or something like that. So when I think of Stephanie, who paid a real artist to put, a cover on her book, well, I'm sorry. Unfortunately, Stephanie is a sucker because you can get that today for 40 cents, right? let's start with correlation. This is the main problem. If we have a lot of data, we can start correlating it together. So if we understand what it means, we can start putting pieces together. If, for example, you have a Facebook account, Facebook probably knows your gender, name, because you might have given that information 10 years ago when you registered, your social graph, obviously, because that's what Facebook is about, people you may know, so that gets creepy because how do they know who I know? And it turns out they are matching GPS locations and things like that. And then your credit card ID, because maybe you put it in Facebook Messenger or something like that, or you paid for something. Okay, but then there's a data broker, so a kind of shady company that is dealing in person's data. Very often you don't know that they exist, and very often you don't know that they are dealing in your data, which in Europe should be illegal, but still it happens. And I have also been a victim of that. And they will, for example, know your visit frequency to a burrito store, the average burrito price you've paid, your credit card ID, the burrito competitors that you've shopped with, the amount of debt you have, because that's financial information that's related to your credit card, and so on. So if these two entities get together, suddenly, using this primary key, they can know a lot about you. They can correlate things. And this is a very, very straightforward example. I assure you that the things that are happening now are much more sophisticated, complex, inference-based, probability-based. There are mathematicians and computer scientists working on developing algorithms that are not precise, but that relate this data with a high level of probability or high degree of probability. But the thing is, it's not only a problem for us, it's also a problem for the correlators, because they are amassing more and more data, which exposes them to many data-related issues. For example, breaches or lawsuits. If, for example, a guy like Max Schrems gets angry that some company is robbing him of his data, he's going to go and take them to court. And so far, he's won quite a few spectacular victories. So companies who are wise understand that it's not in their interest to have, data that enables directly identifying a person, right? And you want to avoid that. So another example that I think is interesting is that one which we've shared already in the previous series that we've done in April of these lectures, which was around the New York Times investigation related to data brokerage and cell phone tracking. So supposedly the data is anonymized to some level. We don't know exactly which one. And then it's being traded freely. Okay, these are just, data paths of some people who are, terminals or cell phones or whatever. And these terminals, it turns out, go inside the Pentagon and then go home. And then these go to a theater, give a show, and then go home. And they guard the president of the United States as a part of the Secret Service organization. And then they go home. And that information is freely available. So if the New York Times can buy it, you can bet any amount of money that the adversaries of the United States have already purchased, used, and applied that data, right? And they've correlated it with other data sources. So the New York Times basically got 50 billion data points from 12 million smartphones all over the US in major cities. And they just purchased it, let's say in a straightforward manner, legally. That data was described as anonymous, but as they prove it is not anonymous. It's not anonymous because you can very easily de-anonymize it. You can basically take the bits and pieces of information, and because location is a type of data that is, very specific to you as a person, it's very easy to make paths and then infer where you were at a given time, right? You can correlate it with known information. The police could buy it, and it does so, and could, for example, say, these people were at a protest, right? And then maybe that protest was illegal. Therefore, everybody who was there and participating was in breach of some kind of a law, right? And this happens in many countries, even in the United States. So all of that stuff is being tracked, and that data is correlated then with other sources of information. It becomes a problem. Another example is here. There's this person on Twitter who said, okay, like many women I know, I use a period tracker app. It's a big help to many women, obviously. And then one time she forgot to put in some information, and the app concluded, well, you're pregnant. And then she started receiving all kinds of advertisements for things, for babies. A lot of communication became kind of bombarding her, because a mother who, kind of goes with one brand would tend to stick with one brand, right? So mothers who are kind of in this early phase of pregnancy are considered to be one of the highest prizes in marketing, right? Because you can spend a lot of money. Obviously, you're not going to save on that baby. Well, and okay, you can say, well, that was, still recent. Maybe this is still developing, or, this is in the digital domain. Well, I have bad news for you, because there's an exact similar story that comes from a decade ago from completely physical retail, right? There was no digital trace there at all. And there was a story about Target, the American retailer, who would know very similar things. So basically, there's, again, a very juicy story from the New York Times about how data analysts in Target would kind of progressively get to the point where they would be trying to figure out which customer is pregnant or may become pregnant, and then they would start sending them brochures for baby stuff and so on. So they said, and this is here, if we wanted to figure out if a customer is pregnant, even if she didn't want us to know, can you do that, right? So ethically, I have a lot of problems with this statement. But then from a legal perspective, I think we don't have the tools, or we don't have the sufficient equipment in order to say, well, that's where it should definitely stop, right? This is not a point where a corporation can come and follow us around in our private lives just to be able to sell something extra. But imagine you're in a country where being pregnant is an issue for whatever reason, right? And the same technology is applied, which was available to a regular company 10 years ago. What will we do then? All this stuff, again, relates to data correlation. I think it's very dangerous. So we don't have much time to dig into this, but if you're interested, I do recommend you look for this story on the New York Times from 2012. It is very interesting stuff. And, you have this long list of things that they would be able to have, right? So link to your guest ID that you would have, from in that store. There's information like your age, are you married, do you have kids, which town do you live in, how long do you drive to the store, which credit cards you carry, if you've ever declared bankruptcy, where you went to college, what kind of topics you talk online, whether you've been giving to charity, and so on. This is a real list of information that they were compiling about their products. I mean, any secret service of a country would be proud to have a file like that on every citizen, right? I'm not saying they should. I'm saying that they often would want something like that. To me, this sounds very, very wrong, right? And this sounds like something we should be opposing. So what do we do to combat correlation, and what do we do to combat these kind of techniques? Well, a first very straightforward technique is fragmentation. So we can try to break up our data so it doesn't represent us in the same way as it normally would. Tester Lin from Boston University says, fragmented data makes it difficult for advertisers to understand the true effect of their ad campaigns. So what she's admitting here is that fragmentation is creating problems, right? It is an effective technique because it limits the advertiser's ability to see what you do. And the advertiser is, just a very easy example. There are many other reasons why we should be thinking about that. So one thing that is related to this technologically is this story about the ID for advertising that used to exist and still exists in Apple devices, which Apple would send, to apps, meaning, that's the person that you were talking to, and across apps, this would identify you. Since iOS 14, you can say, no, I don't want to do that, right? As a customer, I'm not interested in this. And that generated a massive backlash from Facebook, which was one of the biggest companies penalized by this, right? Because they would see, it was a multi-billion-dollar thing baked into a text box, right? And that's what Liviu typically says in his talks, who's sitting here in his room. So I lifted that example from you directly. I think it's an excellent example. If you think about what Facebook is doing, they know that a big percentage, a double-digit percentage of people who see advertising on a mobile phone convert on the desktop, right? So Facebook wants to be able to prove to advertisers that Facebook ads on mobile do bring more revenue, and they want to link those devices, right? So again, they have an interest in correlating because that way they can demonstrate that their thing works and it is worth the money that advertisers pay Facebook to show you things. Another example was Google Chrome, where there's on and off discussions all the time about phasing out third-party cookies. So if you go, I don't know, to the New York Times webpage, you get probably 700 different companies connecting to the data that you might leave there, which means clicks, you know, where did you hover the mouse and so on. And without third-party cookies, it would be much more difficult to do because you will have to go through big advertisers like Google, Apple, or Facebook in order to get that same information. So it will lock more people in to that advertising schedule. So you see that even these things which may be necessarily, you know, good for us as consumers, ultimately are a battle that's way above our heads, right? Between advertisers and those who want to give ads. And these are multi-billion-dollar discussions. Then, you know, how do I fragment my life? Well, there are some other techniques which are more advanced, such as, for example, email fragmentation. There are many services that allow you to do that, where you can have one email address per service that you use. So, for example, if I go to the Canary Islands and I want to do surfing, I am going to give them one email address. And then if I go to my store and I want to sign up for some loyalty program, then I'm going to give them another email address, and so on and so on. So as that data progresses through the system and is probably traded without my knowledge, it will make it harder to correlate things, right? Especially, you know, if they don't trade or I don't share my date of birth or other identifiers that they can use, it will become increasingly difficult for them to do that. But it comes at a high cost to me because I need to remember and know which email address I've given to, you know, every single company. So you have services that help you do that. There's Firefox Relay that, you know, maybe, you know, is something interesting to look at, but there's some criticism about their usage of commercial cloud. There is Simple Login, which was bought by ProtonMail not that long ago. Then there is Anonadi, and then there's many other services that let you do that. So there is a need to do that, right? To fragment your private life, to remain anonymous, or at least to have some degree of privacy. You can go even further. There are those of us who have Android phones with modified operating systems. So it's a version of Android, but maybe cleaned out of all the stuff that is, you know, considered spyware, quote unquote. And there you can very easily create a new profile. And that new profile is, in many aspects, indistinguishable from another phone, right? It is not going to leak a lot of information about you. So to do that, in order to be able to actually benefit from that, you need to take a lot of technical steps. You need to know what kind of phone you have. You need to understand whether this phone is carrier locked or not. You need to understand how to connect it to a computer. You need to understand how to download development tools and a different type of operating system and ensure that it is safe for you. And then you need to understand how to flash that system onto your phone. And then you need to understand what you do in digital life daily, because also your actions can eventually betray you, right? All this dance is not going to be useful if you install some kind of app that is, you know, following you around, that is vacuuming everything you have and you give it the permissions, right? So here I was referring specifically to Graphene OS. Again, I learned more about it from Liviu, who's sitting here. But there are other types of operating systems for Android phones that you could download and potentially, you know, fragment your life a bit, create profiles for the apps that you consider particularly creepy. So then what other techniques do we have there? Well, we've spoken of data anonymization, which means removing personally identifiable information, also called PII, from data sets, so that these sets, this, you know, that the subjects that are described by the data remain anonymous. Very often you use techniques such as suppression, generalization, pseudonymity. We'll look at those at the next slide. But there is a reverse process to that, which is de-anonymization. And that process is sometimes very easy to perform. So what is anonymization? And I've worked on projects like that in big banks, for example. This is something that you are obliged to do and must do. And then there's many techniques. Sometimes these techniques that are applied are very straightforward, but in some cases they are more advanced. So we'll start with the simpler ones. For example, if you want to do blinding, then you just kind of remove the sensitive data. So if nobody is supposed to see CERN in the data, you just remove it or you replace it with X's. Hopefully not, you know, the amount of X's that corresponds to the amount of letters, but you understand. Then you might assign a kind of pseudonymous identifier to CERN. So if we have CERN, the European Space Agency, the United Nations, right, each of those could have a separate identifier. And if we don't know which is which, we might not be able to identify them. Then you could do another type of generalization. So for example, it's not CERN, it's an organization, the name of which starts with a C. right? So we might say CERN, but we might say Crédit Agricole as well, and we don't know which one it is. You could generalize dates by just putting in a range, or you could add a value, add a kind of noise or permutation, and then that is supposed to, change the data a little bit. But there are many statistical techniques that allow you to get to the real values of anonymized data, and very often data is not anonymized very well, and that mixing up is not sufficient to avoid these so-called toxic combinations or mosaic effects, where you combine the whole picture by sourcing data from many different sources. So you can pick up that data from different places, and if you find a way to relate it, then you've created a better picture, and you can even understand how that anonymization was, for example, applied. We'll look at an example that has to do with that on the next slide. There was a paper that basically proved that only 3 pieces of data are enough to identify a person in America, in the US. 87% of Americans can be identified by only 3 pieces of data, and that is the postal code, that is their date of birth, and is their gender. If you have those 3 things, very often you can identify people, and there have been lots of scandals because it proved to be true, unfortunately. So anonymization is a tricky subject. So there's another interesting paper which was called Robust De-Anonymization of Large Sparse Data Sets from the University of Texas in Austin. And basically what they did is they picked up a data set from Netflix, which was issued in the context of them running a prize competition. So Netflix basically said, we want to improve our recommender algorithm. We've anonymized the data. Look at it, look at the ratings that our customers are giving, and please help us help them get good recommendations. Well, what the researchers did is they took the data set, which was 500,000 anonymous, supposedly movie ratings. The data was supposed to be perturbed, the personal information scrapped, only 10% of ratings per customer was supposed to be included. But then the question was that the researcher posed was, how much the adversary actually does need to know in order to identify their record and say who they are. So they picked up open data that is available on the Internet Movie Database, the ratings that people would be putting there, usually under their own name. And when they correlated that in terms of the timing of the rating or in terms of the rating that was given, they were able to identify lots and lots of people from that anonymous data set. And then from that, they could get much more background knowledge, because if I know what your movie preferences are, very often I can know a lot about your political affiliation, about the things you believe in, what kind of stuff you like. So for example, if I like horror movies, and for example, if I like bloody horror movies, well, maybe that doesn't make me a good employee for someone. And that decision will be taken completely in ignorance of any other quality that I might have, right, as a human. So this means that you are exposed in a way that you didn't even think was possible just by joining together different pieces of data. The other thing that I think is a much bigger implication of this is the question of forward secrecy or forward privacy. So basically, when we think about that, we think about the case where data that we thought was anonymous or private stops being private at some point in the future. And you say, you change your identity, right? You disassociate yourself from that data. The problem here is that in your new identity, if you leak anything that can relate you to that previous data that identified you already, then an enormous amount of inference can be made about you, right? And all that stuff, all that thing you did to remain anonymous or disassociate yourself from that is wasted by one tiny move, right? And you might not even know what it is. It could be something very small. So this is a very big topic. We don't have much time to talk about it. And this is not the lecture specifically, but I think this definitely deserves a lot of examination. We should be thinking about forward privacy. And this is one of the main reasons why applying data minimization every day makes a lot of sense, because we do not know what that data will be useful for. We don't know what the law governing that data will be. Once it's out, it's out. So we have to control it very often before it is out. So that data set was not really properly anonymized. At least the researchers were able to go through it without much trouble. So then come in so-called privacy-enhancing technologies. So these are technologies that embody fundamental data protection principles by minimizing personal data use, maximizing data security, and empowering individuals. That's the definition from Wikipedia. there's a lot of discussion still around what privacy-enhancing technologies really are and how they can be classified, what is the taxonomy. There are many, many examples. But they have very often pretty important and valuable aims. To make the data indistinguishable, for example, or the subjects of the data. To make the data or subjects unlinkable. To provide deniability, to be able to say, no, I was not at CERN giving an academic training lecture. That was just my avatar, and you were fooled by something, right? That deniability could be provided by privacy-enhancing technology. The detectability of subjects or data, and then the confidentiality or disclosure level of that data. And then there's many techniques, ranging from cryptography, soft privacy, where there's a third party that can be trusted with processing your data, hard privacy, where there is no third party, and I definitely would recommend that, and then many, many other techniques. So we will look at a few examples in these talks today and tomorrow. Today we'll look a little bit at k-anonymity and then things that are related to that. We might have time to start with differential privacy. We'll see that. And then tomorrow we will look at multi-party computation, homomorphic encryption, searchable encryption, very briefly, and zero-knowledge proofs. I will demonstrate to you how it is that we can prove to somebody that we know something or we have something, some attribute, without actually revealing that attribute. We'll also talk about how we can defend ourselves theoretically and practically. What are the weaknesses of these algorithms in terms of artificial intelligence, but also in other terms. So let's start with k-anonymity, which is a pretty straightforward case. So let's say you have a data table. This data table might have a list of patients and then their diseases, and then it has, their state of domicile, gender, age, religion, or confession. This is a kind of statistical disclosure technique. So basically, you have all this data, and you want to be able to learn something about what's going on. For example, how are the diseases that these individuals have related to the parameters of those individuals? Is one type of cancer more probable after a certain age? Or is one disease more probable for a certain group that is, from a certain ethnicity or from a certain area? Maybe there's an outbreak, and so on. I think the microphone is on. Maybe it's better to switch it off. So a release of data is said to have k-anonymity if the information for each person contained in the release cannot be distinguished from at least k-1 individuals whose information also appears in the release. We'll see an example on the next slide. This is a little bit theoretical. But before we get there, it's important to know about the caveats. So first of all, this kind of technique is not good for high dimensionality data sets. So for example, time series, where there's one individual and they have many records. It's also difficult with using this technique to group records without distorting the data. So then if the data points are sparsely distributed, you could really distort the data. It's not good if the data is correlated, because you can make connections between groups, which you should normally not be able to do. And ultimately, it comes down to bits of information, how many bits of information we're revealing and how much we are digging in. And by the way, maybe I didn't define a high dimensional data set. So it's a data set where the number of features is larger than the number of observations, is much larger than the number of observations you would see. So for example, if you have 6 columns, which are the features, and only 3 observations, then obviously this would be a problem. For example, healthcare data is very often high dimensional, so you have to apply special techniques to it. You don't have any patients, but they have a lot of parameters, right? Or even genomics. The composition of somebody's genome is already saying a lot, right? And you could identify somebody. So then you can use known techniques such as PCA or PCR or, I don't know, feature dropping to reduce that dimensionality, right? And compact the features. So if we want to anonymize, k-anonymize this data set, we would be able to remove the names. Then the age would become a kind of group or range. And then we would remove the religion. Maybe it's not relevant in this case, and we would leave that. So again, we are in the realm of statistical disclosure. That's what normally would be done. And then you would need to apply still a statistical check or a method to ensure that you cannot identify too many individuals in a certain group. So the whole idea is if you make a subgroup of this to a certain limit, you're not able to identify the individuals within that group. This kind of technique is used often in practical applications. So for example, here you see a very well-known service, which is called Have I Been Owned? And there basically you can put in your email address. And by doing that, you're asking the service, has my email address been stolen in some kind of data breach somewhere? And the way that this is done is through the application of k-anonymity, for example. And then Google Password Checkup also used to use this kind of technique. So basically, you would not be able to identify the persons there. And the way this works is that they take a cryptographic hash of one-dimensional data, then they truncate the hash so there are at least k-1 collisions, and then this is very efficient for example, searching passwords. You can't know what the password is, but then you can include those passwords in an anonymized group, and you can say, yes, that password was breached. And for example, if you look at what Google is offering as cloud tools, they also have a tool for data leakage protection, which can help you automatically compute some of that stuff. So they know already that if you want to use the cloud and you want to offer your customers a cloud service, you need data anonymization services and then checks in order to be able to say if the data is anonymized properly or not. But unfortunately, even very big companies make mistakes on this front. So researchers are really having a field day with this. Then related to k-anonymity is so-called L-diversity, so it solves certain problems. You can attack k-anonymity by saying, well, I want to know if somebody is present in the set. And if I know that, then that says already something about me, right? If I am in a patient database, it means I was sick. And if I'm in a cancer patient database, it means I had cancer. And that already can be very valuable information to an insurer who's going to give me a rate adequate to the problems that I have, right? Which means the more problems I have, the more I will have to pay. Other things could be homogeneity attacks, for example. So if all the values of a sensitive values are the same within a set of records, then that sensitive value is exactly what you see, right? And can be predicted for various individuals. So all of this stuff is a little bit tricky. So L-diversity was created to better understand the susceptibility of data sets to attacks. And basically, you say that an equivalence class, this kind of group where individuals are indistinguishable, has L-diversity if there's at least L well-represented values for the sensitive attribute. So if the sensitive attribute is the disease, then we have to have at least L diseases in that set to be able to say, okay, we're not able to reasonably identify what the individuals present in that set might have as a disease. So L diversity of 1 will mean that everyone has the same sensitive attribute. Not so interesting. L diversity of 2 will mean that there are 2 sensitive attributes, and so on and so on. So this concept comes from Cornell University. And then we have T-closeness. So T-closeness basically takes into account the distribution of the values of an attribute in an equivalence class, and then it should be as close as possible to the whole table. So what we mean is if we have this subset that should be composed of individuals that are indistinguishable from each other, the distribution of their attributes, and especially their sensitive attribute, should be similar to that which you see elsewhere in the data set, right? So you try to compose your data set in a way that is representative of the whole data set, and that increases privacy even further, and that makes this kind of decomposition even more difficult to conduct. So now I'll take a look, since we are running close to the top of the hour, I'll take a look at what we should be examining tomorrow. I think, in fact, that it's almost a good place to stop. I will maybe give you a little taster of what's coming tomorrow, and then we will break for questions. So tomorrow, we will talk more about, first, confronting more brainy data vacuums, so the data vacuums that have a little bit more imagination. I asked the AI to represent itself, and this is what it created. It's a little bit eerie, but nevertheless, it is telling, right? There's some kind of human-like construct with brains possibly attached to a lot of vacuums that's pulling in something. So again, it tells you what was embedded in this AI model that generated this. So we'll talk a little bit about that. We'll talk a little bit about practical applications as well. So for example, what does this mean for you as a citizen in a country? How you are related to your government through identity, through money. Can money and identity be made to some extent anonymous? And there are cryptographic and other techniques that are possible to make it so. So we'll talk about those a bit. We'll talk a little bit about automated profiling and automated decision-making as well, how that can take us further. And to illustrate why it is important and why I think it's valuable for you to hear the message tomorrow, is that the AI, so to speak, again, the AI, whatever it is, can go wrong, even for companies that have invested a lot of money in it. Here, for example, you see an instance where a private company based on an AI algorithm, a whole new branch of its business, and that went bankrupt. So basically, they made an algorithm that is able to predict house prices, and then because they didn't bake in enough information into it, the right information, they lost millions of dollars on the investments that they've made. So they would recommend house prices, sometimes they would buy houses and so on, and they had to lay off 2,000 employees because of that. So AI that was not fit for the purpose got people fired at the end of the day, right? So the AI is only as good as the data. It's only as good as the framework and the algorithm that we make, and it's only as good as the people who wrote it. So tomorrow we'll have more examples. Some of them are really very interesting, I would say, almost stunning. Nevertheless, they happen. These are real stories. Thank you very much for listening. I hope to see you tomorrow, and I'm very happy to take questions.
Thank you so much. Andrzej, impossible to get distracted with these talks you give. Congratulations. So yesterday we took first questions from the chat. Let's do the opposite today. Does anybody have a question in this room now? Okay. You can still do it later. I'm looking at the chat. I don't have something right now. I just wanted a clarification very quickly, and then I have a couple of questions very quickly. The Kurzweil guy who said your brain evolves with the data that gets in, is this his personal opinion, or we have any way to find out if that statement is true?
I haven't gotten that deep to be able to answer the question. I'm sorry, unfortunately. But I do think that, the brain evolves continuously, right? And I think we have today methods that can detect whether our brain evolves as we pump it with more information or not. I mean, it is certain that there are new neural connections being formed, and these neural connections then lead us to have opinions, ideas, memories of what happened in the past, and so on, right? At the same time, we don't fully understand the brain and the way that it does its computation, right? It's still a matter of study, and I think that is the point that may be stopping us from fully understand that. But we are certain that the weights that the AI attributes to certain, for example, elements, right? If you build a neural net, then obviously there will be parameters in it, lots of parameters. These parameters change as you feed the network and kind of, retrain it, right, on the data. And that means that the data it has seen make it compute something, right? So for the AI, it's definitely, a true statement, I would say, and that's verifiable.
Thank you. So I would like to take the question by Andrei Dumitru in the chat, asking your opinion on whether regulating AI would help.
This is an excellent question. I think short answer is yes, and we'll talk about that a little bit tomorrow. In fact, I think there are three main ways that we can address, this proliferation of automation, data, AI, and so on. One is self-regulation, and we see where that took us. One is regulation, and I think this is a very valuable tool that we have in our toolkit. I think in Europe it is, relatively advanced, but it doesn't mean that more cannot be done. I think more can be done. And then the third thing is technology, right? So through technology, to a large extent, we can protect ourselves from these kind of schemes that we've been discussing here. And I think that's something very valuable, because with the advent of advanced cryptographic techniques, we are able to reach certain attributes or levels of assurance that allow us to say something about the information our adversary has or not about us. And that in turn gives us a lot of assurance. So I think regulation is a very strong and fundamental component of how we should be looking at those things. In many countries, in fact, there is regulation against automated decision taking, for example. So if the automated decision has a legal-like effect on you, then it can be challenged, or it cannot be emitted, or there must be a human in the loop, and so on. But also tomorrow we'll talk a little bit about the difference between human in the loop and human on the loop, which is a very different, right? Because in the first case, the human must do something actively in order to achieve an effect. In the other case, the human is just supervising. So if you have a tank that is shooting missiles automatically, the difference whether a human is doing that or just watching it is a very big one.
So thank you so much. There is another question by Stefan. Hold on a moment. Stefan, would you like to unmute and ask it yourself?
Yeah, sure. Hello. Sorry, I cannot be physically present in the room. Yeah, it seems that that privacy requires more resources, like specific accounts, more computing power, network, data centers, and everything. So it's not really good for the climate. Is this inevitable?
This is a very good question. I don't know. I don't have a good answer to that. I think it's something that we really need to think about. I believe that as humanity, we should be driving towards having abundant energy, which doesn't damage the environment. And I think, there's many avenues towards that, from renewable energy to, even fusion or ITER, which many of you are familiar with. So I think, first of all, that energy should not be, a long-term criterion for us. Today it's an issue, but in the future, it may become less of an issue. I fully agree with you that it creates a burden. It creates a burden on the client, or, on us as people. And in fact, the sad kind of conclusion or the sad observation is that we are almost at the point where even real privacy nerds are unable to defend themselves reasonably, right? So even if you know a lot about this, you hold an enormous amount of knowledge about this, the system, the soup you are embedded in is really starting to surpass you, right? And is more than you can manage. And, juggling email accounts and avoiding logging in here and avoiding dropping data there is slowly becoming untenable, right? Even for those who are really experienced in technology. So a regular person effectively becomes a subject in this economy, right? They don't have anything to say. And because of that, they are losing agency. They are not able to take their own decisions in the same way as they would without that interference. And that, I think, is a massive societal issue, right? That's something we have to fight, or at least address at a systemic level. We cannot simply say the burden is entirely on the consumer or on the client and so on. That's not a fair thing to do. And this will not end well, because we will be all, like this frog slowly boiled in the pot. I hope that answers the question.
Yes, thank you very much.
Thanks. It's a great question, by the way, and I really think we should think about that.
Thank you so much, both of you. So there is a question by Tsumega. Would you like to unmute, or shall I read it?
I will ask. Thank you.
Pleasure.
So my question was how that kind of regulation could be applied, because a significant amount of the data is shared publicly by the users, for example, in some social media services. But then even, let's say, non-company user programmer can link it in some cases. So should it be like the AI regulation just for the companies, just for the technology, or like including everyone? Thank you.
I think your question touches on an excellent point, right? Which is basically, where do we bake in security in the system? And I think the security really needs to trend towards securing the data and what is happening with the data, right? Today, we get more and more technology that is allowing us to be transparent about things, or, audit that transparency. I'm not talking, I'm sorry, I have to use the B word. We're not talking, just about blockchain. but we're talking about many other technologies, cryptographic included, that enables us to see what is being done with the data, where it is traveling, where it is being used, and so on. And if you look across the board, there are many projects in the world, including some that have been driven by Tim Berners-Lee, who was the World Wide Web inventor at CERN, who has spoken here many times, that drive towards an understanding of the subject where that data is used. So I think, first of all, that work has to start at the level of the data, with control of the data that humans have, and in a way that's understandable to them. And that leads to policies that have to do with data use. For example, in the GDPR, the General Data Protection Regulation, which is a relatively good regulation, I would say, in the EU, you have those notions of the purpose of use of the data. Why is my data being used for which purpose? Do I agree to it? Do I not agree to it? And today we cannot do much. We can write complaints as citizens and say, well, I don't want my data to be used for that purpose. I don't agree to this. I don't agree to that. And then they break, the promise they made and so on. But it has to start somewhere. And I really believe that this goes through data. All these systems that come later, AI and machine learning included, will to some extent be subject to those pieces of metadata describing our private data. And tomorrow we'll talk a little bit about technologies such as, for example, self-sovereign identity that allows us to have a little bit more control over that, right, in a way which is mathematically provable. And I think that will help us also avoid regulation that will stifle the innovation on artificial intelligence or new techniques, right? I'm definitely in favor of innovation and development, and I think there are many excellent companies out there, but it doesn't mean I agree with everything that they do, and it doesn't mean I agree to an indiscriminate vacuuming of the data we have, right? So to me, it starts with the data.
Thank you.
We have a question in the room as well.
I will give you the mic just a moment.
Yeah, thank you for the great talk. Just on this topic specifically, so I don't know much about this, but all of the methods that you describe for anonymity come afterwards. So they're at the analysis level, right? So you have the full data set you're trying to make anonymous. And I was wondering about the policy for this. So is there a way to enforce, let's say, Facebook, to ask them the question, what is this data going to be used for? And they say, oh, we just want to know if you like our advertisement or not. And ergo, with that, create a policy so they can only collect a certain type of data, so not, collect everything that they should. So is there a way to kind of, like a medicine analysis as well, that they don't need, so the final input, so is that a way to create a policy for this, or like to limit them, or?
Very good question. Technologically, yes, it is possible to do that, and there are techniques emerging for that. Practically speaking, there's not a policy that enables us to do this today, right? And I strongly doubt that Facebook would agree to that, because so far, something very dangerous in technology that has been around for a long time is a concept of all in, right? It's everything or nothing. Either you agree to everything or go away, right? If you go to a website, today the website tells you, accept all our cookies or leave, which is illegal in Europe, but nevertheless, sometimes you have to accept, right? I can delete them. But the issue is that by accepting that, you very often also agree to the processing of that data. So just because you remove that cookie or revoked your consent does not mean that they're going to honor it. So there's the data question, which the answer is yes. We can control the data that we send selectively. There are systems or, let's say, technical schemes for that. On the policy level, there's not really much. I think there will be, but right now there's not much. And then there's the enforcement of the policy. I think this is where we are the weakest, right? Because just because there's a law doesn't mean there's somebody to chase people around and say, you should enforce that, you should do that. The regulators in Europe are dishing out Facebook and Google fines, but it doesn't mean these companies are paying them. And this doesn't mean that the practice necessarily stops. I'm not saying that these companies don't take it seriously. They do. But the point is that there is not the mechanism that is, promoting the constraint that everybody sees. It's not a mechanism promoting a universal and agreed view, aligned view of that constraint, right? This is the issue. So I think we still have some discussion to have around that. But I also see very positive signs, for example, from some companies where they give you the toolkits to work on your privacy, right? Or they see that this is something important. It's a topic that's becoming dear and dearer to some people's hearts, and therefore we can put ways of working in place, technical ways of working, and they're doing that in order to minimize those risks, right? So for example, if you look at the talks given by Google about differential privacy or federated learning that have to do with their keyboard called Gboard that you can install on your phone, they go to some lengths to avoid, capturing what you type directly on a server somewhere, right? And put it in a model or anonymize it or envelope it into something that is going to be processed further. I'm not saying this is a sufficient, way to provide privacy, and I wouldn't install that on my phone, definitely not. But it's a sign that these topics are becoming seen, and the policies that you speak of could become reality at some point. But this requires more dialogue, and I think technology is maturing now to that. Thank you.
We have a comment by Sebastian. Would you like to unmute Sebastian?
Yes, hi, thanks. Hi, Andrzej. So, it seems that the automated decision taking will be increasing dramatically in many areas, probably all the possible areas, business, and I think related also affecting humans, medical treatments, political probably decisions everywhere, right? And so far we had this, you mentioned this, you had this kind of notion that there should be some human responsible for those decisions one way or another. But I don't see how this continue much longer. So I'm very curious how you see it, but I guess you will treat it tomorrow. You will discuss this tomorrow in more detail, I assume, or do you want to address this already today?
So we'll talk about automated decision-making and profiling tomorrow a little bit more. I'll give you some examples of what's happening, what are the outputs, and some of these are quite scary, so I don't want to get ahead of that. But you raise a point which I think doesn't necessarily appear in the discussion, which is basically what is the sustainability of what we have today, a human in the loop taking decisions. And I think in order to answer that, we will have to answer a completely, a question that's completely disconnected from technology, which is basically, as humans, are we ready to accept that machines take decisions on our behalf or for us, especially if we can prove that those decisions on average are better than the decisions a human would make. So for instance, if you have imaging software in a hospital that is scanning the images of humans, and that software is better at identifying troubling or dangerous conditions than a human would be, would we be ready to say that we trust the machine more than we trust the human? I'm really on the fence. I'm almost willing to say that I'm kind of willing to go with a better success rate, right, for my condition, because I know that it's going to be, a matter of statistics at the end of the day, right? We tend to overvalue the value of our life, but in the end, it's a statistical thing. And if for society we can create a better outcome for that, maybe that's the thing to do. So I'm not saying we should, delegate decision-taking to machines tomorrow, but I'm saying that before we have that conversation, we definitely need to have a conversation about whether as humans we're even comfortable with that, right? And I think we would see very strong views and very good examples on both sides. And I don't think we're ready to do that. So in terms of the sustainability of the model we have today, I think it will continue, for at least a while longer. And in some domains, we will see the proliferation of decision-making by, decision trees, other types of machine learning or AI, which is going to be probably not very much to our liking because it may be done in a poor way. It may be built shoddily. It may not take into account all the, constraints or all the edge cases that we have there. So I still think we have a bit to go before this can go into very important parts of our life. And if we see that going in, I think we don't have the technological maturity, and we should oppose it, at least now.
Sebastian, you wanted to say something? Okay.
Yes, just to, thank you very much. And I think you really captured the essence of it. And actually, I put even in my comment on Zoom, the need of human responsibility in a question with a question mark, because perhaps this is something we will have to accept, or we will be better off not involving human in some decision processes.
That's right.
And as a good example, sometimes I would perhaps prefer that cars drive themselves rather than some humans drive them.
Well, I mean, I think,
we'll see how this will evolve.
You and I both coming from a country where still the rate of, accidents is very high. I can see how you can mean that, right? And of course, machines can improve a lot on humans, especially where humans are weak. But the thing is, we are very often indiscriminate, right? About the way we suck in data, about the way we distribute it, about the way we apply it, and so on. And this nuance, right? That's a very human thing at the end of the day. So if we apply enough of that, I would be more reassured. But I don't think we're in a position where we do that today.
Thanks. Thank you very much.
Wonderful. It is a pity that we have to stop, and it's a consolation that we have an opportunity tomorrow. So tomorrow, I don't know exactly, and that's the beauty of it, what will be in your talk. But I would like to discuss tomorrow at the end or via your talk one thing. First of all, this graph you showed at the very beginning about the explosion of data, this exponential increase of data to which we are exposed, and how much we have the capacity to adjust to this new bombardment, and what are the consequences for what also you discussed just now with Sebastian, that we can apply the choice to what we want to entrust the machine with and what not. But basically, maybe we are not in the position to decide about everything because it's thrown to us at very high volume and speed. So that would be very nice to debate before everybody is totally hungry tomorrow. And the last thing you said, that you trust statistics and you are probably willing to trust your data to a medical device concluding about your health than to a human. And Sebastian said, I'd rather have my car self-driving itself rather than a drunk, I don't know, driver. It's also a question of generation. That's simply a comment, and I don't know if we can expand, because people may come from an older age where they are more comfortable with humans, and other people, they are wizards from the age of 2 with tablets and the smartphones and computing devices. So that is also an ethical issue. Do we want to exclude the people who are 70 today? Because 70 is not too old.
Absolutely.
So that's wonderful stuff, and so much looking forward to tomorrow, and so much thank you for accepting to this series, and à demain, everybody.
Thank you very much. Thank you, Maria, for your kind invitation. Thanks to the audience in the room for listening, and thanks to the audience on Zoom for tuning in as well. I'm looking forward to tomorrow.